Okay, so let's define more carefully what we mean when we say the word bias. So in general, we would say that the bias of an estimator, so if I'm using theta with a hat to estimate some parameter theta, then the bias would be what's the expected value of theta hat minus the actual value of theta. And so what you can think of if theta is a mean, and we're going to estimate this, say with x bar, then we would compare ex bar, right? And so you can think about this as like the center of the sampling distribution. And this is the actual value of the parameter. And so oftentimes we actually don't know what that is, but some things that we've already seen, and that is when we're looking at estimating a population mean, that the sampling distribution for the sample mean is actually an unbiased estimator because the sampling distribution is centered at the value of mu. And when we're trying to estimate a population proportion, then the sampling distribution for the sample proportions is also unbiased because that sampling distribution is going to be centered at the actual value for P. But of course, in the case that we're in right now, and many times you actually don't know what theta is. That's the whole reason why we're bootstrapping. So when we're bootstrapping, we can tweak our calculation for the bias as so. So we're going to define this as the bootstrap bias to just be sure that here we're not getting the exact bias, but we're getting an estimate for the bias. And rather than take the center of the sampling distribution, what we do is we take the center of the bootstrap distribution. So that's what E theta hat star represents. And then we subtract that from what our sample statistic was. So in the case that we were looking at with Verizon, this is looking at what was the distance between the blue and the red vertical lines that we drew in that bootstrap distribution. So that's how we can estimate the bias. And as you might suspect, we say that an estimator is unbiased if the bias is equal to 0. So again, some examples of unbiased estimators were x bar being used for mu, or the distribution of p hats being used for p. But from our previous example, we saw that for the ratio of the means, we did have some bias. So that was not an unbiased estimator. And so returning to that example of Verizon, let's look at what the bias was and how we can picture that in this example. So again, the bootstrap bias here is we would take the center of the bootstrap distribution, which is that, and then we're going to subtract from that our original estimate from our sample, and we get an estimate for the bias over here. And here that bias is positive, and that's because of the skewness that we had in the tail on the right. So here we have some bias, and the question that you might have is that okay? How much bias is acceptable in order to still have reliable results? So that's what we'll take a look on the next slide.